Okay, so you can see the slides now.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, thank you very much. So once again, you are all welcome to this segment of PCL 322. We're talking about principles of toxicology and toxicity testing, subacute, chronic, and prolonged toxicity. We're going to be talking all about toxicity here. So this is the outline we're going to be looking at. We'll look at some definitions that has to do with toxicology. We will look at the history of toxicology. We'll look at some early toxicologists that we had and how toxicology itself as a study evolved up till this stage, and how we got here, what they did, what they found out, how they were documented, everything about history of toxicology. We look at the different areas where toxicology studies can be carried out, and we will look at acute, subacute, subchronic, and chronic toxicity, and then those response relationships. I am hoping that we'll be able to do quite a bit today. So this is basically the basics of toxicology. It is the study of exposures to adverse effects of chemicals in living organisms. And they've discovered the exposures, the levels of exposures, the different mediums of exposures. We'll look at them, and we'll look at the effect of toxins or poisons on the body or on living organisms. Now, as a way of definition, I would say that toxicology can be defined in many different ways, depending on the angle it is being looked at from. You can say that toxicology is the branch of science that deals with poisons. And that is because before you can talk about toxicology, you have to talk about something that is causing the toxic effects. And in many cases, that thing is referred to as a poison. Toxicology can also be defined as the study of the hazardous effects of chemicals on biological systems, not only on human beings, it could be on animals, it could be on plants, it could be on some other cellular organisms. Every one of these organisms are susceptible to hazardous effects when they are exposed to chemicals that are toxic. And then you can also say that toxicology is the study of harmful effects caused by physical phenomena, not only by chemicals. There are other naturally occurring substances that can result into toxicity. And then, to cap it all, why do we study toxicology is summarized as being the study of detection, the occurrence, the properties, and effects of toxic substances. And having a knowledge of these substances, how do we go ahead to regulate them to make sure that their effects are not deleterious to living organisms? Now, I said that before we can study toxicology, there has to be a toxic effect caused by a toxin. So toxicity itself is said to be a toxic or adverse effect that a chemical or physical agent might produce within a living or a cellular organisms. Once there's an exposure, there must be an effect. There's an inbuilt capacity in any chemical that is hazardous to cause an hazardous effect. We have to know that. And when we have a knowledge of these toxins, we'll be able to avoid them or use them to our advantage, depending on what we want to use them for. As we'll see as we go on. So toxicity also reflects how much of a toxin an organism has been exposed to. It is a reflection of how fast the effect is coming up. And in some instances, it is also a reflection of how long an individual is being exposed to a toxin or a poison. And that's where we'll have the principles of acute, subacute, chronic, and subchronic toxicity coming in. So in toxicity, we observe, we gather data, we record, and then we make use of the records that we have. Now, how does toxicity occur? I've already mentioned that there has to be something that is causing it. And in most cases, this can be a poison or a toxin. Usually, we refer to causes of toxicity as a poison. And a poison can be said to be any substance that causes adverse or harmful or deleterious effects in an organism. It could be a disease state that will be produced or caused. It could be a tissue injury. It could be other interruptions to normal natural life processes that would occur when these toxins when we are in contact with them, when living organisms are in contact with them. And a poison can be of biological origin. If you have looked through the notes that I sent to you, these are part of the notes that I sent to you. How many of you have accessed the notes for last week on PCL 322 on the LMS? I hope majority of you have done that. Have you?
Yes, ma'am.
All right.
Yes, ma'am.
So a poison can be of somebody said no. If there's anybody that has not accessed the notes, please know that you should always check your LMS at your appointed time of lecture. If you are not having a physical class like this, it could be that a note has been dropped for you on the LMS. So you access it, and then later on we'll have a class to summarize all that we have sent to you on the LMS. So please take note of that. So a poison could also be a naturally occurring chemical. Just occurs like a naturally occurring chemical, like lead, like copper, which are in their own rights useful elements, but they could be harmful in some certain situations. It could be a manufactured chemical that has been put together, maybe in the lab, for use in some areas, and then in some other areas, they become toxic. It could also be a result of a physical process. Like, for instance, our cars are moving on the road. They are supposed to have controlled emissions of carbon monoxide, but you have situations or instances where some particular vehicles emit a lot of carbon monoxide into the atmosphere, causing injury to those that are around them at that particular time. And then it could be a process, that builds up and causes injury to the atmosphere in the long run, where we have cases of ozone layer depletion and issues like that. So there are many complications that could occur as a result of toxicity, which might not be as simple to the eyes as we see. You only see the beginning of it. In most instances, unless we have a documentation, you don't know the end of it. And that's why toxicity studies are carried out at times to know, the effect of certain toxins and then have them documented so that we can work with them to turn them to our advantage and prevent the adverse effect that might occur. And then you very rarely have toxicity occurring as a single event. It's not usually a single molecular event. It's a cascade of events that happens as there's a release, and the toxicity occurs when there's a release and cellular organisms are exposed to toxic materials or to poison. There has to be this cascade of events here where the organism comes in contact with the exposed toxin. And if that happens, usually there's an absorption through some various routes that we're going to be looking at later on. And then this also goes on to lead to a distribution of the toxic materials or the poison in the cellular organism. The material could be metabolized to other further toxic substances, and then it leads on to an interaction with cellular macromolecules in the organisms, which then goes on to express the toxicity that we see in various situations. So it's a cascade of events. It's not just a one-point thing that happens as exposure comes on. So if there's an exposure to a toxic material and there's a removal of the organism or the person or the animal or anything from that exposure, at the nick of time, some or all of these events might be circumspected, and then you won't have the end result of toxicity. But when the process goes on, at the end of the day, you have expression of toxicity in the individual. So a poison can also be said to be something that has been made by humans or that is put into the environment by human activities. All the definitions that I've said so far can boil down to it being made by humans or being put into the environment, either knowingly or unknowingly by humans. So we have toxicologists who are involved in the recognition of these toxins. They identify them, they quantify the hazards that result from exposures to these toxins, and then they make public health documentations that we make use of, and which has been of great help today in toxicology studies. So why do we have to bother ourselves with toxicology? Why don't we just go away from anything that causes harm or adverse effects? Why bother? And this, I've tried here to put some reasons why we have to study toxicology, or why toxicity is being studied. Mainly is to protect humans from adverse effects of poisons. Humans at times might not be able to protect themselves from the adverse effects of poisons. But when these poisons are known, when they're documented, and when there are regulations in place, then there will be a protection for people and for maybe other organisms that comes in contact with these poisons. And to also protect the environment, very important. We need to live in a clean and a safe environment. So we need to remove toxic materials from the environment so that human beings, plants, organisms, animals can have access to a clean environment. And then to facilitate the development of selective toxicants that can be beneficial to us, such as in the management of some diseases like cancer, for example. There are some elements that are toxic to the cancer materials, the cancer cells in the body, but might not be toxic to other cells in the body. So there's a selective, use of toxicants to get rid of unwanted effects, either in humans or in plants or in animals. So that has led to the use of some drugs. And it's a principle. When you look at even the common anti-malarial drug that we use today, the anti-malarial drug has been developed to be toxic to malaria parasites without being toxic to humans. So that is a case of a selective toxicity, selective toxicant being used in certain situations. So when we know the mechanisms of action and the effect of these toxicants, we'll be able to use them beneficially for the better part of humanity. So if you want to look at the history of toxicology, it actually dates back to the beginning of time. I put a brief history in your notes. If you have gone through it, you will see the event, right from when man was made. And then it was building up from there until what we have today. And there are different centuries, different eras, different findings, different documentations that we have built on to have what we have today. From the beginning of time, man was always experimenting to know the food that were good, the plants that were good, the plants that were beneficial, the ones that were not good, by observing what happened whenever they take these plants, or what happens whenever animals take these plants. Up until recently, or until the advent of veterinary medicine, we hardly heard of, animals falling sick. You just notice that some animals, particularly in the olden days before the era of civilization, man at that time observed animals that they had. When they noticed some animals exhibiting some traits, and then after a while, they just noticed that the animal seems to be okay. So they wonder what happened to this animal, what did this animal eat, what did this animal drink? And from observation, over time, they were able to document some certain plants that some animals took when they had some certain symptoms and they got better. And man began to experiment with those plant materials. And from there, they discovered beneficial plants that were good for some certain ailments, for food purposes. And we built on that to the era of pharmacognosy that we have today, where we now take plants into the lab to synthesize them and find out the activities, medicinal activities that they have that we can use. So these are the different ages where toxicity passed through. And to mention that, we always say there's a father of modern toxicology. The man Paracelsus is the father of medicine. He's also the father of modern toxicology. He did a lot in toxicology. He discovered some materials and some plant effects which he documented in early writings, particularly in one that was referred to as the Ebers Papyrus. That was more or less the pharmacopoeia of those days. Today we have the British pharmacopoeia, we have our pharmaceutical codex, which we use, where we have documentations of medicines and so many things about them. In those days, this was what they had. And this man was instrumental to the writings that were in this Ebers Papyrus. It contained about 877 recipes and about 400 drugs which were described in that Ebers Papyrus. And a lot of those drugs, were translated, upgraded, and then studied and written up in our pharmacopoeia of today. So Paracelsus did a lot on toxicology studies. And then he was the one that discovered that it's the dose of a substance that makes the poison. It might not necessarily be that a substance is poisonous, which is true. For instance, if I take a cup of ordinary water, it refreshes me. But then put me in an ocean, that's an environment of water, it becomes a toxic situation to me, right or wrong. Am I correct? Do you agree with me on that?
Yes, ma'am.
Okay. And then most of the medications we also have, you notice that we have the dose for them. For instance, take paracetamol, 500 milligrams, 3 times a day. That is the dose that is beneficial to humans. Now, give an individual a dose of maybe 5 grams of paracetamol 3 times a day. It becomes a poison. So the dose is very important when we're talking about toxic reactions and toxicology. Also, this man, Ophila, also was one of those early fathers of toxicology. He was one of those that did a lot also on the science, went into early laboratories to, sort of to extract the active ingredients from some certain plant materials that they had. So I've mentioned that the Ebers Papyrus contains information pertaining to many poisons. For the purpose of this lecture, let me use poison. There are also medications in that document. And then we have surviving documentations also of Hippocrates, who is also referred to as the father of medicine, of Aristotle, who is associated with pharmacy, and Theophrastus. These are some of the examples of early poisons that they discovered then, and they used it in their own way. Number one, they discovered a plant called hemlock. That's the first one here. This plant, if you look at it, is looking like a flower. It's looking like something that you can use to decorate your surroundings. But these men discovered that it could be used as a poison. And the Greeks in particular made use of that particular plant as poisons in their prisons. They use it to execute criminals or execute perceived political opponents. Then we have the Aconite, the second one here, also looking like a flower. It was also used as a poison by the Chinese. They formulated it into something like a liquid and coated their arrows with it, and they used it in their wars then. It became something that they used to win so many wars. You have the opium, which is the last one, and I'm sure every one of us will have heard about that plant, the opium plant. It was also used both as a poison and as an antidote to some other poisons. And then some other metals that were used as poisons. These are examples of poisons, and they are still poisonous today. Their properties have not changed, they are still the same. So these are some of the founding fathers of toxicology. We have Hippocrates, I've mentioned him. He added a number of poisons and then did some work in clinical toxicology. And we have Saka, who also was involved in the manufacture of poisonous arrows. Theophrastus, I've mentioned him, he was a student of Aristotle, and he also contributed in his quota in making references to some poisonous plants, which were also recorded in the Ebers Papyrus. We have this other man, Dioscorides, a Greek physician, and it was the one that first of all made an attempt to classify poisons according to their actions, group them in groups with similar actions, and distinguished one group of poisons from another group of poisons. That was his work. We have Socrates. You must have heard about some of these men. He was instrumental in using poison as a state method for execution, and he was recognized for that work. The ruling people of his time used him, against their political opponents. We have Cleopatra, who also used our own knowledge of toxicology to also develop some poisons and document them in another documentation. We have this king, Mithridates, the Pontus VI himself. He was reported to have used some poisons both on criminals and on himself. And if he was reported to do that, you would know what he did. He used the poisonous ones on the criminals and used a lesser amount on himself to know the effects of this poison. He was reported to have used maybe like a concoction of 36 ingredients to protect himself from his enemies. What was he doing in trying to do this? When he made a concoction of poisons and used it as a protection for himself, it was a form of immunity against any form of poison that he might take in the future. He was trying to build up immunity in himself. And that's a very early reference that we can make to what we have today as vaccines. So this man brought out this knowledge from that, and it was built up upon until we have the development of vaccines, which we are using very regularly today. So he was referred to as the king of poisons based on all these things that he did. We have these other people too. They were all instrumental in one way or the other in documenting toxicology studies and poisonous materials. In particular, this first man, Nicander of Colophon, deals with poisonous animals. Up till now, we have been talking about plant materials. But he went
Whenever I'm
ahead.
having a Zoom class, I'll use it.
Can you please mute yourself if you're talking to somebody? Nicander went ahead to extract poisonous materials from poisonous animals. You can see him there with a picture of a scorpion. He extracted the poisonous material from scorpions when he noticed the effect that they had when they stung people or animals. So he did that. And then Lex Cornelia was the one that made the first law against poisoning. Up till this time, there had been no law regulating the use of poisoning, and people were free to use them anyhow, depending on the dose. You use them against your perceived enemies. You use them to subdue some people to do what you want, to do your bidding. And it was just a free-for-all fight. It was like a survival of the fittest. But then Lex came along and he made the first law against poisoning in Rome. Rome was a big center of civilization then, and had a firm grip or control over the population and the world then. So a law coming out of Rome soon spread over several countries and provinces, and it became law in all other places too. And that's why we also have our regulations today, building up from that time. And then we have Nero. I don't know how many of you read about Nero in secondary school, in your literature classes, if you had a literature class. Okay, so that was the very early ages of toxicology. We now went on to the middle, we'll go into the Middle Ages. If you remember, I tried to show us that there are different eras of toxicology. The one we have discussed so far was the first era, the Antiquity era, where we had very little regulation and control. Now we are moving to the Middle Age of toxicology. So in the Middle Age, you also had some other scientists coming up. And this man, Maimonides, came up. He made use of poisonings from insects, snakes, and some rabid dogs, to create a sort of treatment for people that had been bitten by snakes, people that had been bitten by poisonous insects and mad dogs. And that has evolved today to our anti-snake venoms, I don't know if you have an anti-scorpion venom or something like that, but we have anti-rabies vaccine, anti-rabies medications and all that. It all started from the work of Maimonides, and it's evolved over time. He also did some work on the bioavailability of poisons in the body. And he discovered that when people took some certain food, like milk or some other oily food like butter and cream, it could delay the absorption of poisons in the intestine. We also have that today. It has built up over time. That is why today we know that some certain medications are better taken with food. Some medications are better taken on an empty stomach. Some are better taken with milk. For some, you avoid milk altogether. It's the work of toxicologists with these substances and noting the effects of toxins when people take these substances with them. So after this period, we went on to have, it became when knowledge began to improve. There was a great outbreak of knowledge in that, in this era where we refer to as the Renaissance era. And then people began to, modernize the art of poisoning. They began to bring it up to a higher level than what was done in the previous era. And then it became an acceptable thing for poisoning to be regulated, and then for its use also to be regulated. Documented poisons were known and they were monitored. They were not just free for all to use, they became monitored. And that is why today we also have our drugs that are referred to as poisons, which cannot just be dispensed just anyhow. If you walk into a community pharmacy today, there are some medications that you cannot just buy, even with the prescription, without you filling the poisoning book. How many of you have experienced that? Or how many of you know that there are some medications that you cannot buy without filling a poison book in a community pharmacy? It all came from this knowledge that came in this era, and it was built up on until what we have today. In particular, this woman, Aqua Tofana, prepared some medications, some cosmetics, and some perfumes containing the toxic material arsenic. But still, it was regulated. It was not used commonly, but it was accessible under regulations to those maybe highly placed individuals or king or warlords that wanted to use them against. Can you please mute your mic if the noise is coming from your end? The noise is coming from your end, please mute your mic. So after that, the evolving of toxicology continued, and some other toxicologists came on the scene to also further modify and refine the art of toxicity and toxicology studies. Let me just go through, I will just keep this so that we can go on to some other things and we don't spend too much time. There's a lot of history on toxicology and toxicologists. As I'm scrolling through, just try to read through. Yes, let me mention this man, Orifla. He was the first toxicologist to use autopsy materials. How many of us know what autopsy is? Do we know what autopsy is?
From
Yes,
dead bodies.
autopsy, findings on corpses, to find the cause of death in most cases. That's autopsy. They want to know why or what killed a person. So this Orifla man was the first person to use some materials and chemical analysis on corpses to classify the cause of death based on the poison that was given to people. So he did that, and from then we also moved on. And today we have the study of autopsy. We have autopsy departments in many of our hospitals. Many people that die, particularly when it has to do with some conflicting cases or some court cases, they want to find out the cause of death and then document them for us to know what and how to avoid such in the future. So this man also, Oswald, he contributed his part. Kurt Lewin was the first person to document chronic toxicity on narcotics and other alkaloids. Today, we still have the problem of narcotics with us, but he was the first person to document the toxicity. And then, and so on and so forth. In 1958, we have the first journal that was dedicated to toxicology. Today, there are so many other journals that are dedicated to toxicology. If you go online, you will see so many journals that publish materials on toxicology studies just for the enlightenment of the scientific class. Now, there are these major events I want to bring to our attention that happened in the 1960s. And the first one is the Thalidomide Tragedy. I know that some of us would have heard that. It was the case of where some medications were administered to some pregnant women to try to control early morning sickness. And it did that. The medication controlled the early morning sickness. But at the end of the day, that medication had an adverse effect or a toxic effect on the children born to those mothers. And this is a picture of some of those children. They were born without limbs, they were born without hands. And before this effect was noticed, so quite some time had passed. And I learned recently that the last of this set of children that were born, I think, died the last decade, the last 10 years or thereabouts. So it's very important for us to know what medications we are giving and the effect of it before it's being deployed into the general population. Also, in 1948, there was the development of paper chromatography for chemical separation, which is still being used in our pharmacognosy and pharmaceutical chemistry labs of today. It came from the work of toxicologists. And the use of blood and urine for testing of various chemicals or metabolites in the body, it came through the work of toxicologists. We are built on it today. We are using it to assess the level of medications or chemicals or substances in the body of humans and other animals. Okay, so other toxicologists did some work on the bioactivity of estrogens, and it discovered the effect of estrogen in the body and also the toxic effect of estrogen in the body. The development of neurotoxicity also was by results of the work of toxicologists. So all these things came as a result of the study of toxicology. We knew the effects of chemicals, the effects of plants, the effect of animals, things, and the effect of other substances that were deleterious to the body. In particular, the dangers of lead and arsenic poisoning is highlighted here. I put it here for us to know that it had effects on practically every aspect of the body. And it was something that was utilized as a poison by people, so to say, to cause effects, deleterious effects in their perceived adversaries. And then the effects of that made us to know that today we have to avoid exposures to toxic levels of arsenic, to toxic levels of lead, because lead is a very useful chemical for us, even in our modern day. We use it for so many things, but excessive exposures can lead to nerve damage, skin damage, increased cancer risk, and circulatory problems, which has to be avoided. And then after the World War II, there was the discovery of organophosphates, which is today being used as pesticides. It has been formulated as pesticides to keep pests away from crops, and that has been beneficial to many farmers and has increased the crop production of farmers. At the end of the World War II, we also had the production of quinine as an anti-malarial based on some work done on the cinchona bark. We have moved from quinine at that time, we have moved to chloroquine. We have now moved to the use of artemisinin combination therapy, which is being used as the preferred choice of antimalarials today. So whatever we have in use today can be traced back to early work done by toxicologists of their time, which has been built up and now results in what we have documented in our various pharmaceutical codex and British pharmacopoeia of today. Now let's look at some areas of toxicology studies. I've mentioned that we have so many toxicologists that have done different works. Now, the areas of toxicology has been structured and divided into sections that deals with particular toxic reactions. And I've tried to list them here. I put some of them in your notes. We have the area of descriptive toxicology, where we have toxicity testing for safety and regulatory needs. Toxicity is being observed and it is recorded and it is used for regulatory needs. Appropriate tests can be carried out based on that, based on the exposures to certain chemicals, certain tests, and then they're observed over time to generate documentations and then hypotheses for mechanistic studies. This has evolved into our different clinical trial studies today, particularly when it comes to the use of, the development of new medications. They have to go through some clinical trials, some phases of clinical trials. It's as a result of descriptive toxicology. I will not go into the different phases now, but humans are observed when they are given some medications or some chemicals to use. And then when it's safe in a limited number of people, it is then used on the particular group of patients that medication has been formulated for. And the effects on those patients are also observed, whether beneficial or adverse or otherwise, they're documented. And that determines whether the trials will proceed to the next step, where it will now be used in a larger number of patients, or it will end at that stage. But most of the medication, in fact, all the medications we have in use today went through the stage of being used in a limited number of people, in a limited number of patients, and then a larger number of patients before being released to the general populace. And even after that, we still have adverse reactions being monitored. and people are encouraged to report adverse reactions that they have to medication so that it can be documented, and it can be determined if that medication will continue to be used, if it's going to be modified, or if it's going to be withdrawn from circulation, depending on the effect it has on people. Because there has been instances where a medication would scale through all the clinical phases of trial, and then when it gets into the general population, you start having reports of adverse reactions. So all these are monitored by descriptive toxicologists. Then we have mechanistic toxicology. It's a study of physiological, biochemical, and molecular mechanisms by which toxic effects occur. Okay, these are monitored. Want to know why this effect is occurring in a person, in an animal, or in a cellular organism. And then this study is done under mechanistic toxicology. Usually they are simulated in the lab, and then the effects are monitored. We have regulatory toxicology, and this also goes on to work with our regulatory bodies. It decides if chemicals poses sufficiently low risk to allow for the use or for the marketing of such medications. So we have regulatory toxicologists working in our enforcement agencies, like in our drug regulatory agencies in Nigeria, where they observe effects and they make regulations concerning medications, concerning chemicals that are coming into the country, their effects, short-term and long-term, and then they make regulations on that. We have environmental toxicologists, and these are toxicologists who study the effects of chemicals in the environment, in plants, in the water bodies that we have. What are the effects of toxins on this body of flora? It's not only animals or human beings that are exposed to adverse effects. Plants are also exposed to adverse effects. That's why you see some plants, the growth are stunted, they are not growing well, the leaves are blighted, they are discolored. You want to know why? Environmental toxicologists do all this. Molecular toxicologists, they study the mechanisms by which toxicants modulate cell growth, and then how they also differentiate and respond to toxicants at the gene genetic level. So these are the work of molecular toxicologists. They are also almost always in the lab to observe the effects of certain toxicants on genes, certain toxicants on cells of the body. We have clinical toxicologists who develop antidotes and treatment regimens to militate against poisonings and injuries caused by poisons. Also, we have forensic toxicologists. We have, okay, I've mentioned clinical toxicologists. They work mainly in the hospital settings. And I've mentioned environmental toxicology. All right. Now, how do we classify toxic agents? Toxic agents should be classified according to the target organ. That's the organ where they exert most of their effects. On the use of the toxic agent, it could be classified based on the source where the toxic or the toxicant is obtained from. It could be classified according to the physical state of the toxin, the chemical structure, the reactions that they bring about, and then the poisoning potential. Now, I know that you must know that for toxic effects to occur, there must be a chemical, there must be a reaction. The chemical agent or the toxin must get to the site of action. If you remember the cascade that I mentioned earlier, where the toxicant has to be absorbed, it has to be distributed or metabolized before getting to the target organ where it exerts its action. It could also be excreted, but that might not be before it has exerted an action, the adverse action that we will see. So these are the major routes of chemical entries into the body. We should all be familiar with these major routes. Okay, oral routes, that's through the mouth, via the GI tract. Inhalation through the lungs. Dermal exposure via the skin. We have parenteral exposures. And under parenteral exposures, there are different, parenteral means to be injected, okay? And there are different ways where you can have substances or medications being injected into the body, either for medicinal or adverse effects, since we are talking about toxicology. It could be through the IV, which is direct injection into a vein. It could be peritoneal, which is being injected into the peritoneal cavity. Could be subcutaneous, which is the injection between the skin and the muscle. It could be intramuscular, that's directly into the muscle. Intradermal, directly into the dermis, that's under the skin. And then, apart from these other routes, you could also have occupational exposures, which falls under one of these four routes that we have mentioned. Inhalation and dermal are the most common occupational exposures that we have. People that work in majority of chemical industries, mining industries, they're exposed to inhaling adverse environments, or it could come in contact with them on their skin. And then another route, the last route could be accidental or through suicidal exposures. So these are the common major routes where poisons or toxicants or toxins can get into the body of plants and of humans, animals. Now, when we look at duration and frequency of exposure of toxicants, you could have it as being acute, whereby the person is exposed to the toxin for less than 24 hours. And that is generally a single dose or a single exposure. It's an acute exposure that is at that point in time or less than 24 hours. It could be a repeated exposure. Okay, for instance, somebody is taking something, maybe eating a contaminated food or a contaminated fruit or a poisonous fruit, and you are not aware that it's poisonous. You keep taking it until the effect builds up, we'll see that, and then manifests as toxicity. Exposure could also be subacute, which is repeated for 1 month or less. But when the exposure is repeated for over 3 months, or between 1 to 3 months, we say it is subchronic. A chronic exposure is one that goes on for greater than 3 months. So you know the difference between this duration and frequency of exposures. Acute is for less than 24 hours. Repeated could be subacute, subchronic, or chronic exposure. These are some of the examples of some chemicals that could lead to adverse effects when they are exposed either acutely or chronically. The first one is benzene. When one is exposed to acute exposure of benzene, it usually results in CNS narcosis, the central nervous system narcosis. And then when the exposure becomes chronic, it leads to bone marrow damage or leukemia. So exposure to benzene could be caught at the point of acute exposure to prevent the development of the further damaging effects of bone marrow would manifest in an individual. Also, when we look at some anticoagulant pesticides that are used for our crops, for some of them, acute exposure would have no effect on humans. or plants that or animals that take those plants. But chronic exposure could lead to loss of blood clotting ability in persons who take these plants that the pesticides have been exposed to. Okay, so that also shows the difference in the effects and the timing of exposure of toxicants. And the last one, which is a common one, is this cigarette smoking, where acute exposure can lead to nervous system stimulation, the stimulation that is experienced by those that smoke. That gives them that experience that they want, and they keep on taking the cigarette smoke just to have that exhilaration experience that they have. But on the other hand, when they keep taking it chronically, at the end of the day, it results into different cancers in the body. It could be of the mouth, of the pharynx, and of other organs in the body. So acute exposure and chronic exposure leads to different effects of toxicants in the body. We might also not complete this class today. Hello? Hello?
Yes, ma.
Hello, can you? Okay.
Yes.
Sorry, I got locked up. My internet was a bit unstable, but I'm back now. But our time is up. So we'll conclude this class next week, right after Dr. Shoremekun. Do we have any questions?